Hi, my name's Keith Snell. I'm part of the performance engineering group in the mid-range storage system for Dell EMC Unity products. Here we're going to look at performance analysis. This week we have announced 4 new all-flash systems. These systems have enhanced CPU, additional memory, enhanced file system support that includes compression. We also have AppSync enhancements, including snapshot handling, and we have storage pool enhancements that are dynamic in name and dynamic in nature. With regard to the agenda, we'll have an introduction as to why you may be looking at performance details and going through a performance analysis program. We'll emphasize some elements of the sample period because that's important dependent upon the way that you view the performance data. Now, we have different methods of viewing performance information, and that's the Unity Performance Dashboard, as well as utilizing Uemcli for post-processing data after collecting that data from a customer site. We'll also have some reference to performance archives because you may have some visibility of those at some time in the future. So, from an introduction, typically when looking at performance data, there's 3 use cases. One is a health check. You want to have a look at the system, you want to cross-reference some particular health metrics. Typically that will be system saturation or CPU utilization to see if you're near saturation or whether you have any headroom to add additional workload. Alternative to that, you may want to look at the disks because the disks are ultimately servicing the workload. So those are primarily 2 areas that you may be looking from a health check perspective. Also, you may be looking at capacity planning. Now, capacity planning may be that you want to incrementally add workload to the system. Alternatively, you may be looking to add additional hardware that will service additional workload over a period of time in the future. Alternative to that, you may have been called by somebody that is reporting a problem. Somebody's experiencing high latency on a particular subset of components. You want to drill into that subset only. Obviously, you'll be looking at the high-level health of the system from a CPU utilization perspective, but you may then isolate specific target objects and have a look at the performance statistics for those objects. Now, I mentioned about sample period. You might ask, why is that important? The larger the sample period is where you may find that peak levels of activity are averaged. So you don't see those represented within the data that you're looking at. And this will become kind of more critical as you get less granular with the detail. So why is that important for the Dell EMC Unity product? Well, dependent upon the way that you're looking at the historical database of information, you may not capture some of the peak workloads of activity. So you need to be aware of what you're looking at. The performance dashboard view in particular will vary the way it represents that data when you're looking at it. So as you scroll through the different viewing options, then the granularity of details may change, and you may see peak workloads in one view that disappear when you look into another view. So you need to be aware of that and get familiar with the interface. We say for customized options, you're best looking at post-processing data, somewhat utilizing Excel, for example, and then you can select individual components that you want to do performance characterization on. As a visual representation, let's have a look at the sample period. So here we show an example where the sample period is denoted by A, and in this example we have workload activity in bursts. Over the course of the sample periods, the burst of activity, the peak, would be denoted by the Y. If we change the sample period so that we average the activity over a longer period of time, we can see a significant change in the peak workload that would be represented when characterizing the I/O for that data. So again, this is to emphasize you need to be careful at the data and how you're looking at it. So performance data, where do I find it from a Unity perspective? So in the table here, on the left-hand side, we've got objects. So you've got things like storage processor, LUN, disks, file systems. That's the object level statistics. Across the top, we can see we've got the performance dashboard as well as the Uemcli, and these are the performance options that you've got to retrieve data and have a look at that data and visualize it in some way. Over on the right-hand side, we show archive, and archive is available on the system today with the new OE 4.2, which is announced to be released, well, announced this week, you will have the visible capability to download the archive, but currently the archive is for post-processing data by service and support, but at some time in the future there will be user available options to manipulate the data within the archive. So performance dashboard and historical database is the emphasis of the first exercise that we're going to go through. Here we have a hybrid configuration utilizing a Unity 400 system. We have 18 flash drives and 20 SAS drives. We have a combination of LUNs, so we have 8 SAS LUNs and 8 flash LUNs. Now ordinarily LUNs would be set in a hybrid pool configuration running in an auto mode where the data spanning the tiers within the pool configuration would be moved automatically based on the access characteristics. So the most active data would move dependent upon the skew in that data to the highest tier available. But in this example, we've pinned some LUNs using the tier preference policy of highest available. So we get some flash resident LUNs and lowest available, so we get some SAS resident LUNs, just for the purpose of this exercise. Now the data activity we're going to visualize is an artificial workload, but we tried to make it a little bit more aligned with a realistic environment, so we'll see that shortly. There is a mixture of reads and writes, typically 4:1. It's transactional type data with a variable workload I/O size. The analysis method for this exercise is the Unisphere performance dashboard. So it's primarily used for viewing data from the performance historical database. And this is a database held within the system. You can't externally extract that database. All you can do is view the information held within the database using the performance dashboard. We can pull data out using the Uemcli, and we'll show that in the second exercise. We do also have an option for real-time performance charts. Now these can be useful, but they do offer a limited subset of charting capabilities with a limited number of objects available within those charts. The update period for the real-time is 5 seconds. Now if you have very volatile data activity, they can be challenging to use for kind of useful purposes. For the purpose of this exercise though, we're going to be looking at the historical database that we're going to be retrieving in the charts. Now you do have time selection, you have some preset time selection options or customization. Now these time selection options will denote and affect the sample period that's displayed in the view. So you need to be very careful of that. But it is useful that you can highlight a data point, move the mouse over on the chart and show the next data point and determine what the sample period is that's being displayed in that data. Then you've got the time available, and the time available denotes how far back the historical database can go. And we do retain data, although the data that's retained for more than 3 days extends beyond the initial 60-second sample period to 5 minutes, 1 hour, and 4 hours, depending upon how old the data is. Now we're going to start looking at some data. So here we're looking at storage processing utilization. And immediately, looking at this 1 hour's worth of data, we can see that we get a variable indication of workload on the system. We do see that SPA is somewhat close to saturation at some points in time. And that might be an area of concern if there's other problems with the system. So how is the workload or the saturation affecting the workloads? What activity is contributing to that? So we'll look at some more details. We're going to look at system level stats. Now system level stats are aggregate of the objects selected. So in this instance, we can see that we've got system LUN IOPS. So this will be all the block LUNs on the system, the aggregate of the IOPS for all of those LUNs. And these are typically serviced by fiber channel and iSCSI interfaces for block activity. We can see we're close to 92,000 IOPS at that peak level of activity. If we then add in system drive IOPS, again, this is an aggregate of all activity on the drives, and that aggregate will include file level activity as well, because it is all of the drives. It's agnostic to the front-end interfaces being used for those drives. But we can see, and we know that this environment is fiber channel only. We can see that that 92,000 of front-end activity translates to a back-end drive activity of around 150,000 IOPS. And we do see correlation there of the drive activity to the front end activity. Sometimes that may not be the case. Now if we look at system level LUN response time is averaged across all the components that we've selected, and these are the LUNs. Now that I don't really think is a necessarily useful metric at the system level. It's certainly a key service level representation from an object perspective when we're looking at LUNs and disks, but for the system-wide level, I kind of put that in the grey cloud. Really, it's not really a useful metric. But that leads us on to look at LUN bandwidth, and we need to understand if we're in a bandwidth environment, we might want to pay more attention to the LUN bandwidth and how that's distributed across the ports on the system to see if we've got any bottlenecks there. So looking at port IOPS and megabytes per second, we can see that I/O is distributed across multiple fiber channel ports. If we also correlate the stats to expected levels of saturation for those ports, we can see that we're well under control. So we don't have any issues there to identify. There are additional protocol statistics available within the performance dashboard view. So we're going to have a look at the LUN stats. Now there's a couple of things I want to point out first. You see at the top of the table that we've, top of the chart, we do have that titled Flash LUN IOPS. When we create the table within the performance dashboard, you can't select flash LUNs, for example. You just select LUNs. Then you can select which LUNs you want to include within that chart. Now our LUNs in this simulated scenario are labeled SAS LUNs, the ones that are pinned to a SAS tier, and flash LUNs, the ones that are pinned to a flash tier. And we just happen to select the flash LUNs individually, and we labeled the chart accordingly, so we can customize the view. But we can see here that we have peak levels of activity that's somewhat aligned to when we think the SP utilization was high. And if we now add CPU utilization to the chart view, we can see that simple correlation. Now it may not be that obvious when you're looking at your own data, because you're going to have much more variation in the workload, but it is great if you can correlate front-end activity that's leading to potential problems in the system, like we can do here. If we then look at the flash LUN queue length, we can see we've got periods of high activity, a modest queue going up to around 32, a little bit higher. We could look at restricting the queue from a host side perspective to try and alleviate that increase in SP saturation, but that might have a detrimental effect on other workloads on the system. So we'll look at maybe an alternative method to do that shortly. If we then look at flash LUN response time, even though the system is saturated or close to saturation on storage processor A, around 98%, the response time for these flash LUNs is still pretty good, considering the mixed workload that we have running and transactional type in nature, a little over 2 milliseconds. For the periods of activity when the SPs are more balanced, we are in the region of 1 millisecond or even sub-millisecond response time. So we do need to look at SAS LUN statistics, because typically in your environment, you may just have a few flash drives and you may have several hundred SAS drives, and that aggregate SAS LUN activity could be the contributing issue to the high SP utilization. But we add in CPU utilization here and we see that there's not really much in the way of correlation, so there's not really too much to worry about. If we then look at the LUN queue length and the LUN response time, considering that the queue length is ranging between 10 and 30, the response time around 30 milliseconds may not necessarily be that bad in our opinion. We also might want to look at LUN I/O and megabytes per second, and this might lead us to consider what type of I/O we've got going on with the system. Normally you'd do some homework with the system history to determine what workloads are running, but from these metrics we can determine some level of confidence that with the small I/O size and the relatively low bandwidth numbers, that this is a transactional type environment predominantly. So scenario one review, we've got SP utilization becomes imbalanced at some period of time. We've got response times are kind of within acceptable levels, even though we are very high system saturation. But if we wanted to consider any incremental workload on the system, I'm sure that's going to lead to problems. So what would we do in that instance? So there's a couple of options available. We could isolate those particular workloads. We could look to migrate those onto another system and bring them out of that system so they're not affecting the utilization. Or we could utilize a really neat feature within the Unity platform called host I/O limits, and that's what we're going to do here. So, a quick overview on host I/O limits. The simple dialog box, we can set a limit that's either shared resource against targeted objects, or we can apply it to individual objects. And in this instance, we set a target limit of 4,800 IOPS, and then we've targeted those against the LUNs that we identified earlier as the contributing LUNs to the SP utilization increase. So, because this was a synthetic artificial workload that ran over a period of an hour, we are able to rerun that workload. So just to recap, the SP utilization was hitting peak loads around the 98% mark when we had those high levels of activity on those LUNs. Here we're showing that. Now, when we rerun that test over a period of an hour, we can see that where we were saturating the CPU on SPA before, we're now running a very reasonable 43%. And you can see from the table on the right that the workload profile for the host I/O limits is active, and we have this 4,800 limit, and that's applied to those particular LUNs. But what's it doing from a LUN perspective? I mean, we know we've got utilization is maintained within a good range. The host I/O limits is applied to the targets only, and we'll verify that as we look through the presentation. Now, we can dynamically adjust the limits and also pause and resume the profile as necessary. So first look at the SAS LUN IOPS, and we don't see much change there. Also the response time, there might be some effect on response time because of the available SP utilization. But when we look at the flash LUN IOPS, we can see that the targeted LUNs that the profile was set against is running at 4,790 at this data point, so it's very close to the target 4,800. But also we can observe that the other LUNs that were not targeted with this profile are still able to maintain a higher level of IOPS than the limit applied to the targeted LUNs. If we then look at the response time, then we can see how those limits are applied. Effectively, we're delaying the response in acknowledgement of the I/O for those LUNs, but to a balanced controlled level to try and hit the target that we've set for those LUNs. So the summary, the storage processor utilization was high. We identified from a health check perspective how to, well, what was actually the problem, and then we decided to employ host I/O limits to affect a change and reduce the impact of the SP utilization. So we're going on to scenario 2. Someone's reporting a problem. So here we've got similar configuration setup, but the change here is that we've got a varied workload profile, but we get a call from an operator, and he's complaining that as he's running a monthly report, an increase in the workload on the system, he's observing unacceptable behavior in response time. So what we try and do is isolate characteristics of when that problem is occurring, also what objects. So fortunately, the chap that called told us what LUNs we had to look at, and we're going to focus this investigation on a subset of SAS LUNs and the SAS disks. But we'll also look at SP utilization from a health perspective. Now, we've got Uemcli options for retrieving data from the historical database. We have the same historical data retention available to us with this data. We have approximately 77 metrics available to retrieve using CLI commands. And here's a couple of examples of the CLI commands used in this exercise. Now, I mentioned before that in the performance dashboard, we have real-time capability. And we also have real-time options available within the Uemcli framework. And we have many more options available because it's real-time, and because we're not retaining those levels of performance metrics, you know, in excess of 500. And there's a couple of examples there that you can take away offline and have a play with your own system. So what we did, we retrieved the data, we then brought it into Excel, and utilizing pivot charting, we can display the data in a reasonable way that aligns somewhat similar to the performance historical database performance dashboard view that we saw earlier. So in this instance, we're having a look at the SAS LUN IOPS, and we can see that at the period of time that was reported, the workload is scaling up in IOPS, but it seems to hit a plateau. Now, we only understand and can observe that because we have discussed that with the originator of the problem, and he was indicating that the workload was increasing and he was hitting unacceptable levels of response time. If we add in response time, we can see that we're going from kind of around 10 milliseconds and we go up to 50 milliseconds response time, which could be pretty unacceptable dependent upon the application that's accessing the disks. So the observations we got there is that we do pinpoint the scaling workload that the end user was reporting, but we do have a response time impact. Now at the area that we've highlighted on the top chart, we like to do some math with regard to the aggregate IOPS that we can attain from a different way of pivot charting the data. I'm not actually showing that here, but we were doing around 4,000 IOPS as an aggregate. We can do the math with RAID 5 implementation and determine a per disk IOPS based on the configuration service in the workload. And that comes around to 320 IOPS per disk. So we want to have a look at the disk IOPS themselves, and we can see that we're doing well in excess of that 320 IOPS. We got that highlighted here. So our observations: the scaling workload pushes the drives above the recommended levels when we cross-reference against the Unity best practices guide, which denote for a 10K drive it should be maintained under 250 IOPS. It's not necessarily the case always, but it's a clear indicator from a health check perspective that we might want to do something to alleviate that problem. Because we're looking at it from a health check as well, we do want to have a look at CPU utilization. I'll just pop that chart up there, and CPU is well within acceptable limits of utilization. So we're going to employ pool expansion, and we've got a few screenshots here, just the simplistic method of dynamic pool expansion, where we're going to double the amount of drives in the SAS tier, which will redistribute the existing LUN distribution, and that will redistribute the I/O across these additional resources and hopefully alleviate the problem that we're experiencing with the plateaued performance and increasing response time. But we're going to see that. So we see that we're adding 20 drives to the pool, and the net result is we end up with a pool that had 38 drives. We've now got 58 drives, namely 40 drives in the SAS tier, and these LUNs that we're experiencing the problem are pinned to the SAS tier. So if we just recap where we were before, we have a look at the LUN IOPS, and just to say that we've got a reasonably nice picture here in a real world environment. It'll be a bit more erratic with different IOPS levels between the different objects within the environment, but we've got 4 LUNs on SPA, 4 LUNs on SPB. That's why we have 2 lines of activity. But we can see that we kind of hit a plateau, so the aggregate throughput is somewhat limited. So Tom, can you tell us a little bit after the expansion, we can see that we get much better scaling capability up to the full workload potential of those drives. We get lower contention, utilization, and hopefully response time. So looking at response time, what happened before? It didn't take too long as the load was increasing for the response time to go up and increase to around that 50 millisecond mark. And now after we've expanded the pool, we redistribute the load, our response time is much more acceptable, even to the point of the highest workload level going to close to 20 milliseconds, much lower than the 50 milliseconds, and this is much more acceptable for that end user. We do want to have a look at the disk IOPS and see what happened there. We could see before we had disk IOPS in excess of 400 because we were saturating those drives, and now because we're redistributing, we'll lower the utilization of those drives, and we subsequently lower the throughput on a per drive basis. So Uemcli statistics match the capability of the performance dashboard, but allow us to retrieve data independently to being having access to the system. Now, we identified resources required to service the workload were exhausted, those SAS drives. We decided to utilize dynamic pool expansion to add 20 drives to the pool, and that allowed us the ability to redistribute the data and subsequently distribute the workload and reduce the response time to acceptable levels. So I mentioned earlier that we've got a facility called Performance Archives. You may be familiar with previous generation products where we had archives. These are somewhat similar, but they are used for escalation and support services. But with the OE 4.2 release announced this week, there will be visibility of the archive download, and in future releases there will be availability to extract data from those archives. But the archives themselves contain 1 hour of data. It's in a SQL database format. The resolution or sample period of that data is a bit better than the historical database. It's 10-second data. It contains many metrics that help support services in escalation calls. The repository is guaranteed to contain at least 48 hours worth of archive data. So that enables a very fine, detailed analysis of that information. If you wanted to have a look at the structure of the database, you can download a SQL Browser Lite program and pull the database apart. But because of the format of the database, it is somewhat complex with regard to aligning timestamps to actual time events because of the epoch offset that is embedded within the archive data itself. But useful if you are looking to import data into your own database structure. So we've seen that we have multiple performance viewing options by way of the performance dashboard if you have the luxury of access to the system. We've seen that you can post-process data by pulling data or retrieving data from that historical database using the Uemcli commands. And we provided a couple of examples and an example of how to list the full suite of commands or metrics available. We highlighted the sample period considerations, and in particular, if you are using the performance dashboard view, you want to really get familiar with the effect on the sample period dependent upon how far back and how much you are looking at in any given point in time. In the examples provided, we did isolate some issues. We found out that by doing dynamic pool expansion, we could redistribute workload, lower utilization. We found out in the first exercise that we could utilize the benefits of the embedded host I/O limits on the Unity platform to reduce utilization, targeting specific workloads so they didn't run away with resources. So I'm hoping that this session has helped you bring up your confidence level so that on your digital journey with the Dell EMC Unity platform, you're well suited to address any potential health concerns and any issues that may arise in your environment.